Okay, let's get started. I want to do a bunch of things, right, this lecture, and there'll be a lot of them. So, let's see. I guess, first of all, I want to figure out how many people here are still on the wait list and not yet into class. So if we could have a poll on the iClickers of how many people are still in on the wait list. And 98, 101, 2, 3. Okay, over here. All right. Okay, so we now have 4 people who are still not in the class, but on the wait list. And if you could come up afterwards and tell me who you are, I'll then try to figure out what's going wrong, because there definitely are more than 4 slots left in the, definitely more than 4 slots still open in the class. The sections, office hours. So far, for 2 weeks, I've had office hours from 2 to 4 up in Evans Hall 601. And so far, in 2 weeks, I've gotten 4 people who want help getting in off the wait list, and 3 people who want to talk about the course. And that's not enough. And I understand that in the past, say back before they painted Evans Hall, back when it was still kind of raw concrete with no paint at all, just kind of bare concrete, especially in the days when the concrete skin was flaking off. And so you would look on it and it looked like it had a really bad case of acne and needed Accutane or something. And then there was the year when people got annoyed trying to open and shut the windows, which got jammed because they were low quality windows. And I think 3 times these 4-foot by 4-foot panes of glass came off their runners and went spinning out, falling down on the ground beyond from a height of, say, 70 feet in the air. No undergraduates or graduate students were hurt, but we could understand why people didn't really want to come to office hours in Evans in those days. But now we have a freshly painted Evans, we have redone windows, it's now in very attractive colors, so it no longer looks quite as much like the Ministry of Truth from 1984, and yet still you people aren't coming. And one possibility is that usually I get undergraduates, because usually something like 2/3 of the undergraduates who take my courses are either engineering majors or Haas majors who are naturally already higher up on the hill than Evans Hall is, and so since they're walking downhill, it's easy. But if most of you are people who spend your lives revolving around Telegraph and Bancroft, it's a climb, especially if the elevators are jammed and you have to walk up the 6 flights because the elevator never comes. So I'm thinking of adding more office hours down here, probably on the patio outside the Free Speech Movement Cafe. When would you be likely to come if I were to add office hours either before or after lecture on either Tuesday or Thursday? If I can add 1 office hour time to my existing ones, which would people like to see? Because, 3 undergraduates in 2 weeks for a class of this size is not enough. I understand that a lot of Berkeley education is relatively anonymous, that this is kind of like the Costco of universities, rather than the, Macy's or the Neiman Marcus or the Nordstroms of universities. But still, we have our pride. Oh, no. All right, it looks like Tuesday afternoon is probably the thing that's going to get the most. So let me try, not next week. Next week I have a pointless bureaucratic meeting Tuesday afternoon after class. But let me try afterwards, going from lecture straight over to the Free Speech Movement Cafe at 12:30 on Tuesday afternoons and see who shows up, whether that's a good thing to add to this course. And let me mark that as the thing that I'm actually going to do. Additional, problem set 2. Problem set 2 is now up on the internet, and it's due Thursday, February 3rd at the beginning of lecture. It's also simple and relatively easy to do, problem set 2. And again, the hope is that almost everyone will get almost everything on it right. And as for problem sets in general, I wouldn't sweat it. I think that problem sets are going to be worth 4 points per problem set. And, it's of those 4 points, you don't hand it in, you get a 0. You hand it in late, you get a 1. You leave large chunks of it blank, you get a 2. You do it perfectly, you get a 4. Everyone else gets a 3. And you can get up to 2 points per problem set by regularly clicking your iClicker, whether your answer is right or wrong. So I think that everyone should wind up getting pretty much perfect scores on their problem sets, provided they hand them in on time, and provided that they actually don't leave virtually the entire thing blank. So I want you to do them. I don't want you to go absolutely crazy over them. And I wouldn't greatly sweat them if you have other important things to do. They're points, but you can make up those points with iClickers. And it shouldn't be, failing to answer question 8 on problem set 5, shouldn't be a big negative impact on your grade. However, I do want you to learn things from the problem sets. And one thing it seems to me would be good to do that usually works in these classes is to have recapitulations, to reinforce in your brains the things I really want you to know and take away for the rest of your life from this course. And one of them is how much bigger total world GDP is now than it was 10,000 years ago. That in this 10,000 years of agriculture and industrial and now post-industrial society, we've seen human populations expand from 5 million to 7 trillion. We've also seen the world get richer. How much richer? How much do we think world GDP today is, very roughly, very approximately, is larger than it was back 10,000 years ago, back when cities had names like Catalhayuk and had maximum populations of, say, 1,000. And yes, we are now up at 87% with what I regard as the right answer, about 17,000-fold increase in global world real GDP. Populations are about 1,200 times larger than they were 10,000 years ago. Average standards of living are about 14 times bigger than they were 10,000 years ago. Multiply those things together, you get 17,000. Although it is somewhat a silly question, what the answer is really does depend on what your tastes and preferences are, and everybody is different. And furthermore, we living in this society have very different tastes and preferences to large degrees than our hunter-gatherer predecessors of 10,000 years ago. And making such comparisons should kind of scare you. They do require enormous leaps of assumption and imagination. Second thing I want you to remember for the rest of your lives is what the unemployment rate was when you were taking IAS 107. So once again, what's the unemployment rate right now? And for this, 10 seconds should be enough. more people showing up, which is good. Yes, we got it. I'm still accepting answer B because that's the seasonally unadjusted unemployment rate in December because of this traditional standard 0.3 of a percentage point wedge caused by the fact that December is a high employment month because of the Christmas rush. And let me warn you that in 8 days that number is going to change. Because in 8 days, the Bureau of Labor Statistics will release its survey of the unemployment rate as it was in the second week of January. And so the latest unemployment number will probably be a little bit different from 9.4%. It'll probably be 9.3% and then stay there for a month or so. But this is a question, the answer to which can change. Third thing I want you to know about is Say's law. Right? That is Jean-Baptiste Say's claim back in 1803 that we really didn't have to worry about an economy lacking demand. Because if there's deficient demand for some goods, there has to be equal excess demand for other goods, because nobody plans to sell anything without planning to buy something else useful as well. And as John Stuart Mill pointed out back in 1829, there's something deeply wrong with Say's law. What is it? Yes, the answer I want you to give is B. That the thing wrong is that people spend their incomes not just on currently produced goods and services, but on financial assets as well by building up their stock of financial assets. And the other four answers are reasonable ones as parts of theories of why there are depressions, why there are times of high unemployment. But B is, I think, the central crux of any model of why we're undergoing a period of high unemployment like we are now. And B is what I want engraved on your brains. In some ways that Say's law might be true. Or might be nearly true, is itself an astonishing claim. That is, my old teacher back when I took a course that I guess is best thought of as a combination of Political Economy 100 and also IAS 102, Methodology of the Social Sciences. Back then, we had two teachers for the section. Jeff Weintraub, now at the University of Pennsylvania, and Shannon Stimson, now in our political science department. And Jeff sent me a quote last week from a book by Cambridge, England economist Frank Hahn and Stanford economist Kenneth Arrow, General Competitive Analysis, about how the very idea that you could have an unplanned, decentralized economy where everyone runs around and does what they think is best to get themselves more wealth, how it can possibly be that this can add itself up and be coherent and organized rather than simply a total sea of chaos. So in some ways, the surprising thing is not that Say's law is false, but that it is so close to being true. And that even when Say's law is false in theory, a skillful technocratic government can, with minor interventions of the economy, make it true enough in practice for it to be a reasonable guide. And indeed, something like Say's law, that big problems of the economy not having too much demand, of the economy being disorganized in the sense that people are making lots of things that they cannot sell, this has been a big problem in the American economy, I'd say only 3 times since World War II. Very briefly in 1974-75, rather longer in 1982-84, and unfortunately for us, in 2008, and it now looks like the depths of the downturn will stretch out until 2012, since we got some more bad news this morning about the state of the labor market. But still, that's only 10 years out of 65, during which a shortage of demand has been a big problem. That means that 80% of the time we should be worrying about other things, one of which is long-run economic growth. We have John Stuart Mill's explanation of why Say's law is false, but there is, looking at this picture, another natural question about John Stuart Mill. Why does he have the same hairdo as Carrie Fisher does in Star Wars? It's really remarkably close, except for the bald part on top. And then there's the fourth thing that I want you to learn. And that's how to use the growth theory equation that Robert Solow of MIT won his Nobel Prize in economics for thinking up and for teaching us how to use. How to use this growth theory equation to do calculations. That is how to try to figure out what the level of output per worker in an economy ought to be as a function of a relatively small number of different but important factors. That's a fourth thing that you had better learn. And in fact, let me see how many people can actually learn it. That is, here in the first line, we have our growth equation again. That output per worker. To figure out what output per worker is, you need to take the capital intensity of the economy, which is the savings rate S, divided by this sum of 3 terms, the population growth rate, the efficiency of labor growth rate, and the depreciation rate, the rate at which capital wears out. You need to take that quotient. You then need to raise that quotient to this rather peculiar exponential power of this parameter alpha over 1 minus alpha. You then need to multiply that whole thing by the efficiency of labor E. So suppose we have these values for all those parameters. What then is output per worker? What then is output per worker in the economy going to be if it's on its steady state balanced growth path? That's a calculation I want all of you to be able to do, because then you can go out and confront the real world. And if you're trying to understand why is a particular country right now rich, or why is it poor, it will direct you to the factors to look at. And then you can go and a level deeper and say, if in this case this country is poor because the efficiency of labor is very low, you can say what it is. Good, we have a plurality getting the right answer, or at least what I think right now is the right answer. If I remember how to do this. S over n plus g plus delta is 2. Raise it to the alpha over 1 minus alpha power, that's 4. Multiply it by 10,000, you get $40,000 per year. That half of you are already able to do that in real time in 30 seconds is, from my perspective, a good sign. When I was looking over the little bit of arithmetic I've done so far at the start of the course, it struck me we should do a little more math. That is, calculating compound growth rates is a genuinely useful skill to have in the front of your head. That a whole bunch of processes in the world will either take the form of exponential growth or exponential convergence, of quantities that are either moving away from their initial value by an amount that compounds over time. Like compound interest, like population growth when there's abundant resources, and being able to have how to analyze such numerical questions in your head is very useful. And then those mathematical skills also carry over to systems that are approaching a stable equilibrium, systems that are undergoing the inverse of exponential growth, that is exponential convergence, in which they're making a constant proportion of the way toward their long-run asymptotic value over time. Now, if things are easy, if you're just doublings or halvings, or some simple multiple of that, you can use the rule of 72, and that the rule of 72 you should be able to keep in your heads. Why the rule of 72 rather than the actual number that the engineers will tell us, which is 0.69 something or other? Well, first of all, if you're considering annual growth rates in the range between 2 and 8%, rather than continuously compounded growth rates. 72 is actually a closer approximation than 69 point whatever. And second, 72 is a wonderful number because it has lots of factors, right? 2, 3, 4, 6, 8, 9, 12, there's no 5, 18, 24, 36. Divide 72 by any of those numbers, and you get a nice number without a fraction. If you're going to be wanting whole number answers and be able to quickly compute things in your head, it's much better to have a number that when you divide it by a whole bunch of things, you get an answer without a fraction. That's just cognitively easier. That's why we use rule of 72. But if you don't have it easy, well, that's why the one who is made microprocessors for us to use. And you need to figure out which particular formula you want to plug into your calculator. And in general, there are two sets of formulas for going from growth rates on the one hand to cumulative growth factors on the other. And it really depends on whether you're an accountant or an engineer. Right? That accountants take a growth rate, they add 1 to it, and then they raise it to a power t. And engineers, they take the growth rate g, they multiply it by the time t, and then they raise this to the exponential power, the exponential function e, where e is 2.71828. They both work perfectly fine. It's really a cultural difference, whether you're a basic accountant or an engineer. Let's see if you can use it. Here we have Botswana. Right? GDP per capita in Botswana in 2010 was $15,000 per year, about a third of the U.S. level. But by the context of the world as a whole, not that poor, especially when you consider that GDP per capita in Botswana in 1960 was only $900 per year. How fast did real GDP per capita in Botswana grow, approximately, between 1960 and 2010? So if you've got your calculators, now would be a good time. If you want to try to do it in your head, that's fine as well. Okay. All right. We're doing okay. We're flat. Flat's too bad. Right answer is going to be C. And if you want to do it in your head, what you should do is you should take 15,000, divide it by 900, and say that's about 16. And 16, 2, 4, 8, 16. 16 is 4 doublings. And if you have 4 doublings in 50 years, that means you have 1 doubling in about 12 years. And by the rule of 72, a quantity that doubles in 12 years, well, 72 divided by 12 is 6. So the answer ought to be about 6. And answer C is the only thing that's about 6% per year. So that's the right answer. Or if you're swift with your calculator and can actually make it work on demand so quickly, you could get it that way. That's a very hard thing to do under pressure in 30 seconds. It is, I think, a thing that's worth having in your head. Yeah? Okay. All right. Well, 15,000. We have a laser pointer. No, we do not have a laser pointer. All right, I'll bring the laser pointer next time, rather than gesture vaguely at the screen. All right, that you go from 900 to 15,000 in your wealth in 50 years. That's about a factor of 16, which is you're doubling it to go from 1 to 2. You're doubling it again to go from 2 to 4. You're doubling it yet a third time to go from 4 to 8. You're doubling it a fourth time to go to 8 to 16. So if it doubles 4 times in 50 years, that means that each doubling takes about 12 years. And how fast is a quantity growing that doubles in 12 years? Well, to determine that, you divide 72 by the amount of time it took to double. And 72 divided by 12 is 6. So it's growing at 6% per year. And that's what answer C is going to be. That's a useful thing to have in your head, even if you spend most of your life sitting in pointless bureaucratic meetings, because then you can make points and make people impressed and also understand the issue better if you can move back and forward between growth rates and total growth accumulations with relative ease. And indeed, here we have Botswana on Hans Rosling's wonderful gapminder.org website. What's happened to Botswana since 1959 in its rate of economic growth, with all of the kind of shadowed out points being where the countries of the world now are back in 2009. The big red ball being China, the big blue ball being India, this being Nigeria, this being Ethiopia. I've forgotten what this is. Large African country in real trouble, possibly Zimbabwe. I think it's Zimbabwe. United States, the kind of sun-like thing up there. Japan, the thing with the greatest life expectancy up there. So it's a relatively large pink ball. Between 1959 and 2009, Botswana changes from looking like a typical underdeveloped, poor, heavily agricultural African country to a country that's kind of smack in the middle of, say, the orange European scatter, and significantly richer than most of the yellow South American scatter, with one big difference. Life expectancy in Botswana now is 55 compared to 70 for other countries with about equal levels of GDP per capita. This is because of the AIDS epidemic. An economy with lots of migrant male workers like Botswana and others is going to have a high rate of infection of AIDS, and for reasons I do not understand. AIDS is a much more virulent and destructive disease in Africa than it is in the rest of the world, even conditional on relative levels of wealth, on how much wealth you have to devote to public health and to anti-AIDS drugs, and so forth. Starting in about 1985, you can see the public health of Botswana collapse as life expectancy starts to drop like a stone as people begin dying of AIDS in very large numbers before recovering somewhat in this past decade. But that public health disaster to the side is the only large negative about Botswana's growth over the past 50 years. Otherwise, it's been an incredible trajectory, while most of the rest of the world is simply growing relatively